I like it.
Yeah.
All right, very cool.
So up next, we have a few more apps from the Grasshopper program. This next application is one of the more technically ambitious projects I've ever seen. The Fongsoons have built a blockchain app for reducing food waste, all with a very slick mobile interface. I don't want to say too much about it and steal their thunder, so without further ado, here are the engineers behind Potluck.
Hi, everyone. My name is Ruth Hill. My teammates are Lamona Wyatt, Natalie Ung, and Oxane Rivera, and we are thrilled to introduce you to our social blockchain app, Potluck. Potluck is designed to redirect food that might otherwise go to waste through personal networks. If you have unwanted food that others might still enjoy, you can use Potluck to trade it with others in your network. To facilitate these exchanges, we wrote smart contracts in Solidity, the language designed to interact with the Ethereum virtual machine. Most of you have probably heard of Bitcoin, but we were excited to explore alternative uses for blockchain technology outside of cryptocurrency. Smart contracts allow our users to exchange items in a conflict-free manner that provides transparency within their network and builds trust over time. We used Web3 to communicate with our contracts, Express to route our server-side data, Postgres to organize our users and their items, and React Redux to organize it all into a smooth, straightforward user interface, which Lamona will tell you more about.
Thanks, Ruth. We leverage reactability to manipulate the virtual DOM at every step of our trade. So here's Jamie. She bought a big bag of apples and there's no way she can eat them all, but no worries because Potluck is here to help. She just adds them to her pantry and now everyone in her network can see that she has apples up for trade. Mark is in her network, so let's take a closer look at Mark's rendered view. When he selects the apples, it updates the state of the app, removing the item from his market. This is due to React's ability to quickly make and compare changes in a virtual DOM, only updating the view with the items affected by the change. So back to our swap. Once Mark sends Jamie a trade request, she gets a notification in her inbox. Now she can look through his pantry, select items, and send a request back. When Mark accepts the terms of the swap, it fires off a sequence of events that update their Ethereum smart contract, our database, and the way the view is rendered. And here's Natalie to speak more on that.
One of the challenges we encountered was managing the flow of data through our app. We needed to update the contract every time there was a status change, and to make sure that we were connecting information between the front end, our private blockchain, and our database. For example, let's say that Jamie and Mark have traded their items in person. When Jamie clicks the Complete Swap button, this dispatches a call to a Web3 route, which is a library that allows us to communicate with our local Ethereum node. We use this Web3 route to run the Complete Swap function that we defined in our Solidity contract. This sends a request to the blockchain to update the contract instance. Since this is an asynchronous request that requires both users to confirm, our route waits to receive the result. When Mark clicks on the Complete Swap button, he also runs this function and completes the terms of the contract. This dispatches an update to our database, and our Redux store fetches this information, rendering Potluck points on each user's profile. I'll now pass it over to Oxane to talk about our app's architecture.
Thanks, Natalie. The way Jamie interacts with the blockchain in our app is through an Ethereum client called Geth, which is an implementation of the Ethereum network, but using Google's Go programming language. Now, the Geth client starts running as soon as Jamie registers on Potluck by creating a local copy of the state of our network that includes the blockchain, which we later call a node. Afterwards, Geth connects this node to all the other nodes in our network. Now, by having every node become a copy of the blockchain's data, we're able to implement one of the blockchain's key concepts, which is to create a decentralized peer-to-peer network. We also added a server-based implementation to our network system because the computational power needed to mine each block, as well as the memory necessary to add the blockchain, to download it and copy it, would be too taxing on some of the users that we envisioned would use our app. Therefore, we have Geth create and store all the nodes in our own server and made our own machines mine the blocks necessary for transactions. Thank you for listening, and be sure to visit Potluck at potluck.market.
All right, quick reminder, if you're into blockchain and food sharing, like the post, like the pinned comment. That's really cool. I'm a big fan of blockchain type stuff. And I'm also a big fan of communities of sharing. And I often find the problem is that oftentimes they're not infiltrated, but they're ruined by freeloaders. And yet they don't want to impose currency like, USD, because it's like USD has all kinds of culture around it, right? So currencies like this kind of stuff is like a perfect kind of middle ground of, I want to contribute, I want to share, but I don't necessarily want to charge people for my 5 Granny Smith apples.
Yeah, 100%. I give them a lot of credit for taking a very hot and growing area of technology, blockchain, and thinking of an original, non-traditional use case for it. I mean, anyone in the blockchain space right now is thinking cryptocurrency, ICOs, et cetera. So it was nice to think of something a little more wholesome, a little more community-oriented that still leverages this very new, very exciting technology.